If you want to make a farming related project for yourself or for a client, then you must watch this video from start to finish. That's because in this video, not only we will cover the pH sensor, but I will also explain how to upload a program to the ESP32 S3 module using a USB to TTL converter, how to add the RP2040 board in the Arduino IDE and upload a program to it, how to modify existing codes, how to change the sleep time intervals so the battery can last for months, how to split the entire string message and save different values into corresponding variables, how to use long-range LoRa transceiver modules to send battery voltage, temperature, humidity, and soil pH values from the transmitter side to the receiver side. At the end, we will visit the fields and check the soil's pH value in different areas to understand how pH affects plant growth. Today, I received this parcel from Maker Fabs. They provide a wide range of services and products for makers, DIY enthusiasts, and electronic hobbyists. Honestly, I was so excited about this package that I couldn't wait at all, and as soon as I got this box, I opened it right away. Inside this box is the industrial grade soil remote monitor, which we can use to monitor humidity, temperature, and soil pH value. For you guys, I'm going to do the unboxing again, so without any further delay, let's get started. This is the receiver side which we will use for monitoring. And this is the LoRa antenna which we will connect to the receiver. The wire is quite long, and if installed outside, the LoRa communication range can increase up to around 5 kilometers. This is the sensor that we will use to monitor temperature, soil moisture, and pH values. The sensor has stainless steel rods. Insert these rods into the soil to read the temperature, humidity, and pH value. This sensor looks just like the NPK sensor which we use to measure soil nutrients like nitrogen, phosphorus, and potassium. I have already made a detailed video on the NPK sensor where I monitored it using an Android application with Arduino and the HC-05 Bluetooth module. So if you want to learn how to detect nitrogen, phosphorus, and potassium content in soil, I highly recommend watching that video. I will add a link in the description. Anyway, this sensor is connected to Maker Fabs AgroSense LoRa-based sensor module through a long wire, and this module is completely waterproof. To power this whole system, a 6-volt and 1 ampere solar panel is connected. Let's start with the receiver side. This is the Sense LoRa receiver V1.0 based on the RP2040 and the 868 MHz LoRa transceiver module. You can also get the same receiver module with 433 MHz and 915 MHz LoRa modules. With this receiver, you also get a micro SD card for data logging. Here is where you will connect the antenna. This receiver also has a display where you can directly monitor the sensor. If you want to monitor the received data on a computer, you can connect this receiver to the computer using this USB-A interface, which I will explain later in this video. On this side, you can see there are 3 push buttons: display rotation button, burn button, and reset button. Let me also tell you that this receiver is completely open source. You can download the schematic, PCB design, and program from Maker Fabs GitHub repository. Now let's go ahead and connect the antenna to the receiver and mount the bracket on the solar panel. Although the sensor and solar panel are connected to the AgroSense LoRa-based sensor monitor, it still won't work because it's off. To turn it on, we need to open it. As you can see, this button is currently off. Before turning it on, let me explain a bit about the other components. Here the solar panel wires are connected. Here you can connect a 1000 mAh battery. Since batteries were not allowed in the shipment, so they didn't send one. So that's why I have connected this small LiPo battery. I didn't have a pH 2.0 connector, so I soldered the battery wires directly. This is the LoRa transceiver module, and next to it is the ESP32 W-Room1 Wi-Fi plus Bluetooth module. On this side, you can see the sensor wires are soldered. You can desolder these wires and use the pH sensor with an Arduino or any other controller board you want to use. On this side, you can see I have also soldered female headers. Normally, it's ready to use because the company has already uploaded a program to it. So when you open it, you won't see male or female headers. But if you want to upload your own program, you will need to solder male or female headers here so that you can easily use a USB to TTL converter with it. Don't worry, the headers are clearly labeled. On the bottom side is reset, IO0, RXT, TXT, ground and VCC. I will explain later how to connect the USB to TTL converter and upload code to the ESP32S3 module. Also, like the receiver, the AgroSense LoRa-based sensor is completely open source. You can find the circuit diagram, PCB design, and program for this board on the MakerFabe's GitHub repository. To configure and set up the remote side sensor, first place it outside so the solar panel can charge the battery. As you can see, the red LED is on. Next, turn this button on and quickly press the other button. You don't have to do this every time, only when you need to change the ID or the interval time. Then open your browser on your laptop. Press the Wi-Fi button and select MakerFabes from the list. Then click on the connect button. Enter the network security key, which is 12345678. Once connected, enter this IP address. Using this web page, you can set any sensor ID you want and also set the interval time in seconds. The default interval time is 3600 seconds, which is equal to 1 hour. If you use this interval, you will get the sensor reading after every 1 hour. The advantage of using a longer interval is that the battery won't discharge quickly. So this way, you can even use a small battery for months. Anyway, let's say we want to get the sensor reading every 10 seconds. To do that, we will enter 10 seconds in the interval time box. And now I'm going to use the same sensor ID. Finally, click on the setup and restart button. If you can see the set success message, then congratulations, you have deployed your remote sensor monitor successfully. Now, the remote sensor monitor will send the soil condition based on the set interval time. Remove this part of the URL and press enter. If you get the error, your connection was interrupted, or a similar error, it means the Wi-Fi connection was lost. As you can see, the MakerFabes module is not available in the Wi-Fi list. To fix this issue, you need to restart the remote module. Whenever you change the sensor ID or interval time, always restart the circuit. As you can see, it is connected again. In the list, you can also see that our laptop is connected to the MakerFabes module. You can see the same sensor ID and the interval time is changed to 10 seconds. In the same way, you can change the sensor ID or interval time at any moment. Let's change it to 20 seconds. I'm going to select the same sensor ID, but if you want, you can select any other sensor ID. Finally, click on the setup and restart button. Done successfully. Remove this part of the URL and press enter. If the web page doesn't open, it means the Wi-Fi connectivity to the MakerFabes module is lost, which you can confirm by clicking on the Wi-Fi button. In the list, you can see the MakerFabes module is not available. Now, to fix this, simply go and restart the module. Once you restart the module, click on the Wi-Fi button. From the list, select MakerFabes module and click on the connect button. You can see the interval time is changed to 20 seconds. After making the desired changes, turn this button off and then turn it on again. After that, tightly close the cover. The transmitter side is now fully ready. I've placed it outside again so the battery can charge during testing. Anyway, next we will start with the receiver side. We don't need to do any settings on the receiver side. It's ready to use. We just need to connect it to the laptop and wait for 20 seconds. As you can see, we have received the values. If you don't want to use it with a laptop, and want to make it completely portable, you can use my designed 5V and 3A power supply. I have already made a detailed video on this. With this circuit, you can use any power supply from 9V to 25V. Right now, I'm using this 4S lithium-ion battery pack that I made myself. I actually made this battery for my racing drone. If you want to make the same 4S lithium-ion battery pack, you can watch that video. I will add links to all the related videos in the description. Anyway, as you can see, it is receiving the data wirelessly through LoRa and printing it on the OLED display module. Now, if you want, you can also see this data on the computer. For that, you will need to download the SSCOM32E software. Make sure to select the correct communication port and baud rate. Right now, you can see we are getting new data every 20 seconds as we selected a 20-second interval time during the transmitter settings. Not only this, you can also send this data from the receiver side to any IoT cloud platform. I will explain this in one of my upcoming videos. Anyway, if your main goal is just to monitor soil pH, humidity, and temperature, and you don't want to make any changes to the programs, then your work is done here. Because the next thing I'm going to explain are only for those who want to program both the receiver and transmitter sides. It might be a little boring, but trust me, you will learn a lot. Anyway, first let's start with the receiver side. To use the Sense LoRa receiver with Arduino IDE, first we need to install the RP2040 board in the Arduino IDE. Let's do it. While the Arduino IDE is open, go to the Tools menu, then to Board and click on the Boards Manager. Type RP2040 in the search box. Install the Arduino Mbed OS RP2040 boards. Make sure you install the 4.0.4 version. This version of the RP2040 is recommended by the manufacturer. Anyway, once you have installed this specific version of the RP2040 board, next you need to confirm if it's available in the boards list. For this, go to the Tools menu, then to Boards. You can see the Arduino Mbed OS RP2040 boards has been added. You should see Raspberry Pi Pico, so simply go ahead and select it. This is the complete program for the receiver, which, as you know, is based on the RP2040. As I already mentioned, this is an open source project and you can find the circuit diagrams, PCB design files and programs in MakerFabe's GitHub repository. I also downloaded this code from there. First, we need to install the required libraries, and let me tell you, you must install the exact same versions. I have already installed all these libraries, so let me show them to you. After installing the board and all the required libraries, next you need to go to this path and change the SDA and SCL from 4U and 5U to 6U and 7U. Open the pins_arduino.h file. Set pin_wire_SDA to 6U and set pin_wire_SCL to 7U and then save the file. Next, connect receiver to the laptop and upload the program. For this, select the Raspberry Pi Pico board, then select the correct communication port and finally click on the upload button. You can see the code has been successfully uploaded. The transmitter side is already on. Let's wait for 20 seconds to see if it receives the data or not. Perfect. The receiver has wirelessly received the data, so this means the program we uploaded is working. Now we can modify the receiver program as per the requirements. I will do it later in this video. For now, let's move on to the transmitter side. This is the complete program for the transmitter side, which we need to upload to the ESP32 S3W Room 1. But before that, you need to install the ESP32 board in the Arduino IDE, just like we installed the RP2040 board. I have already made a detailed getting started video on ESP32 where I explained the board installation process. You can find a link to that video in the description below. This time you don't need to install the libraries because we have already installed all the required ones. The final step is to upload the program, and as you know, we need to use a USB to TTL converter for this, so let's do it. I have already connected USB to TTL converter. Its wiring is so simple. Connect the VCC and ground pins of the USB to TTL converter to the VCC and ground pins on the AgroSense LoRa-based sensor module. Connect TX to the RX. Connect RX to the TX, and finally connect the IO0 to the ground. For the connections, you can follow this circuit diagram. Connect the USB to TTL converter to your laptop. Next, on the AgroSense LoRa-based sensor module, turn on the button. Now, go to the Tools menu, then to Board, ESP32 Arduino, and select ESP32 S3 Dev module. Again, go to the Tools menu, then to Port, and select the correct communication port. Finally, click on the Upload button. You can see the program has been successfully uploaded. Now, remove the USB cable and also turn off the button. Next, remove all the wires if you no longer want to make any changes in the code. Don't forget to turn on the switch before you tightly close the cover. Our transmitter side is now completely ready, and right now it's transmitting the data. Let's power up the receiver side to check if it's working. Perfect. We received the data, which means we did everything correctly. But it's quite hard to read the values. Let's remove the ID, count, and sleep values from the display. This is the received message format. We have to split this entire message and save the ID, count, sleep, battery voltage, temperature, humidity, and pH values in the corresponding variables. Then we can apply certain conditions on any of these values. Let's say when the battery voltage falls below 3 volts, we can print a message on the display, or we can generate a notification message. The same exact thing we can do with the temperature, humidity, and pH values as well. For now, I don't want to add any conditions, but I want to remove the ID, count, and sleep values from the display. So let's go ahead and modify the receiver side program. I create this burst message function, which takes only one argument of the type string. This will take the received message as an input, and then using these instructions, we extract the ID, count, sleep, battery voltage, temperature, humidity, and pH values. I have commented the ID, count, and sleep values, and I'm only printing the battery voltage, temperature, humidity, and pH values. You can download this modified program from our website electronicclinic.com. I have already uploaded this program, so let's go ahead and watch this in action. Now you can see the display is very neat and clean. We can easily read the battery voltage, temperature, humidity and pH value. Now I will dip this sensor in water to check if the humidity and pH value change or not. We will have to wait a bit. As you know, we have set the interval time to 20 seconds. This is simply mind-blowing. Humidity value is changed to 100% and the pH value is changed to 6.8. Next, we are going to test this sensor with dry soil and then we will also add some water. Let's do it. Right now, you can see the soil humidity is 6.3% and the pH value is 7.3. Let's go ahead and add some water. The soil humidity value is changed to 16.10% and the pH value changed to 7.5. Let's add some more water. It's working exceptionally well. This time the humidity value changed to 23.5%, whereas the pH value remains the same. I have come outside towards the fields to check if it's true that tobacco farming damages the soil because it makes the soil acidic. And this is what we are going to find out. But first, let me tell you, for most vegetables, the soil pH value is between 6.0 and 7.0. Soil pH value below 6.0 may cause nutrient deficiencies, especially phosphorus and calcium, whereas soil pH value above 7.0 may cause nutrient deficiencies, especially iron, zinc, and manganese. Here we have some chili plants and most of the leaves are turning yellow. Let's start here and find out the main reason behind these yellowing leaves. I have inserted the pH sensor into the soil and placed the solar panel a little distance away. I powered up the receiver side using a 4S lithium-ion battery pack with my 5V and 3A power supply. On the display, you can see that the pH value is exactly 7, which is the upper limit. A pH of 7 means the soil is neutral. One thing I noticed here is that almost all the farmers are only using manure as organic fertilizer. Manure is made from animal waste, usually from farms or livestock. This is making the soil more alkaline because manure increases the pH value of the soil. It's good to use organic fertilizer, but using too much can harm the soil by making it too alkaline. There is some manure already here, so let's check its pH value. As I said, this type of fertilizer increases the pH value. So let's see what the receiver shows. You can clearly see that the pH value is 7.5, which confirms that only using manure raises the soil's pH. If the pH value is 7 or above, the soil becomes too alkaline, which can limit the availability of nutrients like phosphorus, iron, and manganese, causing poor growth and yellowing leaves. According to experts, the best pH range for chili plants is between 6.0 and 6.5. In this range, plants can absorb nutrients better. So now we know why the chili plant's leaves are turning yellow. In this field, as you can see, there hasn't been any planting yet. Let's check the pH value of this soil as well. I think the pH here will also be high. On the receiver, you can see the pH value is 7.5. Meaning this soil is more alkaline, so it needs special treatment. Some plants may grow well with this pH, but trust me, the type of plants grown here need a pH below 7. Now let's move to the tobacco field. The tobacco season is over, but before I start testing, let me tell you, for tobacco cultivation, the ideal soil pH range is between 5.8 and 6.5, which is slightly acidic. This pH range helps the tobacco plants get the nutrients they need and grow healthy. If pH is below 5.8, the soil is too acidic. It can lead to nutrient imbalances, particularly deficiencies in calcium and magnesium, which are vital for tobacco growth. If pH is above 6.5, the soil becomes too alkaline. It can reduce the availability of key nutrients like phosphorus and potassium, leading to poor plant development and lower quality leaves. Maintaining the pH within this range is crucial for successful tobacco plantation, ensuring good leaf texture and quality. I noticed tobacco plants with mostly yellow leaves, and when I spoke to the farmer, he said the plants didn't grow well. Anyway, let's first check the soil pH and then discuss it further. So let's check the soil's pH value on the receiver. I'm completely shocked. This pH value is not acceptable for tobacco plantation. The pH value of the soil should be between 5.8 and 6.5. The soil here is too alkaline because the farmer is using the same fertilizer as before. I confirmed this by talking directly to the farmer. I also asked about the plant growth and the leaf color, and according to the farmer, the tobacco plants didn't grow as they should. I must say every farmer should have this pH sensor. It's very easy to use, comes with a solar panel, and is completely waterproof. It has a good range, so you can monitor your fields from home. In upcoming videos, I will also show how to use this pH sensor with an IoT platform. So that's all for now. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode, and thanks for watching.